Add the WeatherTrak option to a SolarVu energy portal to track performance and receive alarms when problems occur. Let's find out how WeatherTrak uses weather sensor data to help manage a solar PV system. Additional sensor hardware is included when the WeatherTrak option is purchased with a SolarVu energy portal. This consists of a silicon irradiance sensor that is calibrated to closely match the characteristics of a solar panel. An internal temperature sensor tracks the panel temperature, and an external temperature sensor measures ambient temperature. It is possible to add an anemometer for wind speed, but this is usually not necessary. The powder-coated IP65 aluminum WeatherTrak sensor module is typically mounted to the frame of a panel in the same plane as the solar panels to measure the irradiance incident on the array. Panel temperature is tracked using an internal temperature sensor exposed to the same condition. This reduces installation time that would otherwise be required to fasten an external sensor to the back of a panel. The ambient temperature sensor is mounted in a convenient shaded location nearby. Wires are terminated in the supply junction box. A single outdoor-grade Cat5 cable is run from the SolarVu enclosure, usually in the electrical room, to the WeatherTrak junction box on the roof. Both power and communication are included in the single cable, which reduces site labor and wiring costs. Connect the 5 wires as shown in the wiring documentation included in the door of the NEMA 4 SolarVu enclosure. Weather data is now ready to be collected and stored in the SolarVu servers for the lifetime of the system. After WeatherTrak is installed and the SolarVu enclosure connected to the internet, use a browser to access your SolarVu portal by typing in the site URL. Click the Analyzer tab and select WeatherTrak in the Tools pull-down box. In addition to measured irradiance, panel, and ambient temperature, WeatherTrak computes additional useful values. Compare the insolation and peak irradiance today with the energy and peak output in the live view. Check the actual output power against measured irradiance to determine how closely the system is generating to design capacity. The graph is scaled so that the rated AC capacity on the left axis matches the full irradiance of 1,000 watts per meter squared on the right axis. Factors like temperature and higher DC panel capacity than rated inverter AC output will significantly impact the achieved output. If output and irradiance do not track as expected, look for causes like shutdown inverters, soiling, snow coverage, and bad strings. A peak recorder that can be reset for a new time period is included. The temperature minimum-maximum log shows how cold the panels get in winter and how hot in summer. In the live view, check the actual generated energy on the day maximum installation was recorded to see if the system reaches its full design output. Weather values are also displayed in other views to help determine what is happening. For example, in winter, the irradiance may be high, but the system output is very low. When looking at a snowcam photo, if the maximum daily temperature displayed is below freezing, it explains why there is a limited output due to snow coverage, because it's too cold for the snow to melt. For detailed performance analysis, daily installation and energy generated values can be downloaded in a CSV format for custom spreadsheet manipulation. Create your own calculations and reports from WeatherTrak measured values. SolarVu stores data for the lifetime of the system so you can analyze any time period of interest. Even if you do not have time to do detailed analysis of WeatherTrak data, its biggest payback can be preventing lost revenue by automatically detecting faults using analytics. WeatherTrak continuously compares the output power of each inverter to the measured irradiance. If WeatherTrak detects that any inverter is producing less than expected, it sends a sun low power warning email. A description of the problem with timestamp, inverter ID, and measured values is included in the sun low power warning email. A link in the email goes directly to the analyzer tools to get more details of what the inverter is doing. When a sun low power alarm email is received, check the matching time period for the identified inverter in its 30-day equipment log to see all measured values, including fault alarms. This detailed information will allow quick diagnosis of the cause, such as a bad string, inverter fault, grid issue, or blown fuse. In this example, the second inverter maximum power point tracking input is showing no power. Operations and maintenance staff should look for a bad string connected to this input on inverter number 4. Without WeatherTrak, this condition would be hard to find, or worse, go unnoticed. To ensure WeatherTrak reliably detects problems under all irradiance conditions without creating nuisance alarms, flexible user-adjustable settings are provided in the Setup Equipment screen. Leave settings at the factory default levels or adjust them for desired sensitivity. Set the minimum threshold to deactivate alarms at the beginning and end of the day or for low sun conditions. Reduce the alarm sensitivity by decreasing the trigger point as a percentage of the expected rating. Increase the time delay to prevent short-term variations from generating an alarm. You can also reset the min-max log to start a new measurement period. It is difficult to detect if a single-string inverter is underproducing by looking at total system output alone. WeatherTrak ensures that an underperforming inverter will not go undetected. A 20 kilowatt inverter that is not generating at a 63 cent per kilowatt hour fit rate will result in over $1,000 per month in lost revenue. On large multi-string or central inverter systems, WeatherTrak will quickly pay back its initial investment by early detection of faults with diagnostic tools to expedite maintenance. Use WeatherTrak to study system performance, explain unexpected output variations, have peace of mind that the system is operating correctly, and quickly identify faults when they occur. Expensive operation and maintenance site labor is minimized by knowing exactly where to look to restore operation. Consider adding the WeatherTrak option to a SolarVu energy portal for any system 50 kilowatts and above. If it prevents only a few days of lost revenue due to early fault detection over the lifetime of the system, it will quickly pay for itself.